I'm actually going to type in a program now and we'll see what happens when we take it from being text file or a .c file all the way through to being a program that the computer can understand. So first of all, there's some things that look a bit weird, but I'll explain them as we go. We type include that stands for standard I/O. Now the first line on line 1 here is hash include then stdio.h. That looks a bit weird and don't really worry about that for now, but basically it just includes, this will get replaced with the text from this file called stdio, which is short for standard IO, and it's a bunch of things that will help us. It includes certain things to save us time later on. Now what we have here is called a function, and that's something that gets executed by the CPU as a subunit of code. Now in C everything happens within what's called the main function. For now don't worry too much about these parameters inside the brackets here. We're just worried about this printf statement on line 4, and that's a mistake. And the main thing is to not worry about this at the moment. We're just going to compile it and see what happens. Now when we compile it, we have to go to the command line and I have a directory called CT. Now to compile this, a compiler is a program that will take that text file, all this stuff, and make it into machine code for us. So it basically goes through and converts our English looking C code into machine code and saves us having to go through and transpose everything by hand. Now to get this to work, I'm using an open compiler called GCC, which is a publicly licensed compiler. So you type GCC, then the name of the source file, which is ex1 from example1.c, and then a directive which is telling it what will be output, which is just ex1. And looks like everything went okay except for a warning. We didn't have a new line. Not sure if that's a good or bad thing. But now if I do a directory, you can see that there's our source file, which is just the text that we wrote in the text editor, and there's the executable file ex1. So if I type that, first I'll clear the screen, type ex1 and it runs, and it printed that. That's what printf did. Now have a look a bit closer. We can see that printf is also what's known as a function. But we're not going to worry about functions at the moment. I want to show you some other things that we can do. So we can get the computer to do maths. And to do that we need to set aside some memory, so what I'll do is set aside some memory to hold an int. Now we looked at ints in the last video, and that basically an int is 4 bytes of memory, and it's a whole number. There's no decimal part to it. So we can make an int called myInt, and we can make it equal to some value, say 666, and then we can print that out using printf. Now this looks a bit weird, but what we can do, don't worry too much at the moment about how this looks. Now I save this as ex2.c. Let me go back and we'll try and compile that. Now there's a bit more to compiling than just running the program, but bear with me, it'll all make sense in time. Now what I'm just going to do here is change this. Just to explain this again, GCC is the name of the compiler, and all this afterwards are parameters to the program, so it's going to use this information. It's going to go and get this file and make it into ex2 executable. The O here stands for, that's the output I want from GCC. So if I haven't made any mistakes in the source code, it will work. And that's technically not correct, there might be mistakes, but if there's no syntax errors, it should work. And this time it worked. So if I type ex2, we get the number printed out that was stored in memory. So what we did, we made some memory. Now, as I said before, memory is just a series of numbers, numbered address locations. What we're doing is giving that memory a name called myInt, instead of having to remember what the number is. Now, interestingly enough, you can find out what that memory address is, and you can do that by simply printing that out. The ampersand is used to find out the actual number, not the value of myInt. We'll find out, what we're going to do now is find out the address in memory, and it'll be a big number in hexadecimal. Actually, I'll keep it as decimal, just out of interest. So we'll name this exercise 3, and we'll see if it works. Change these to 3. And it worked. Type ex3. And what that tells us is at memory location 2,293,620, our value 666 is stored. So that's interesting. But we're using, instead of that